Hello friends, welcome back to my channel, and today we are back with another exciting video. In this tutorial we are going to learn about OpenStack. So I'm really excited, and I believe you are also very excited to learn about OpenStack, and this will be a very good tutorial where we'll be completely learning about OpenStack from basic to how to set up OpenStack. So I'm sure you're going to love this tutorial. So let's get started without any ado. So in the agenda, what we are going to see, what we can expect from this tutorial. So we are going to talk about what is OpenStack. Okay. So before to get into the OpenStack, I want to give some basic introduction about cloud. So we'll talk about basic about what is cloud, why we have to use cloud, and what are different kind of cloud service models, so you can get an idea. And then we will talk about OpenStack, and why we have to use OpenStack and what is the benefits, those kind of things. And we'll also see about OpenStack deployment models and mainly the architecture. So different components in the OpenStack and what each component does, and what is all these services as part of OpenStack setup. And we'll also talk about all these components, as I mentioned, each component as part of OpenStack architecture. We will talk about that, and we'll give you the complete overview on that. So, and then at the end we will also see how you can set up OpenStack. So once you set up OpenStack, you will get the web page where you can log in, and you will be able to see what all these services which we spoke as part of OpenStack, which you can start using. So that will be the overall agenda for this tutorial, and I'm sure you're going to enjoy this and you can learn a lot from this tutorial. So don't skip any part, just keep watching till end of this video. So this will be a complete OpenStack tutorial for beginners. So since we are going to start from the beginning about cloud, OpenStack, how to set up OpenStack in our environment. So this will be a complete OpenStack tutorial for beginners, and you have to watch completely starting from beginning to end, so you can have a complete overview of OpenStack, and then you can set up your own OpenStack environment. So before I get started to the actual discussions, I would request you, like if you are new to my channel, or if you have not subscribed to my channel, I would request you to click on the subscribe button. Also like my videos, share, and give your comments in the comment section. Give your feedback in the comment section, so we can understand what you like to see more, and what improvement I have to do. So now let's get started with the introduction to cloud. Okay, so if you see on this picture, I don't know how many of you have seen or heard about these names like Alibaba or AWS, right? Amazon Web Services, or Google Cloud, or Microsoft Azure, VMware, Oracle Cloud, Salesforce, right? So I'm sure some of you would have heard about it. If you don't know about this, no issues. We are going to talk about what is cloud as a basics in this section. And I'm sure you would have heard about Gmail, right? Most of everyone would be using Gmail as your email account, right? And you'll have also seen YouTube, right? You use YouTube, you use Facebook, right? And some of you would have heard about Salesforce service. So there are different kind of applications, like have you ever thought about like how Gmail works or how YouTube works, right? There's so much of data, we are sending emails, we are having a lot of our attachments, you are having a lot of YouTube videos uploaded, you are streaming it. Have you ever thought about where these data getting stored, right? So all these applications are running on cloud, and based on our requirement, it can easily scale up the application, scale down. It can store, in a in cloud environment, so that it can be accessible by everyone. So there are a lot of benefits of using cloud. So, but just want to give you some of the example, like Gmail or YouTube or Facebook. So those of some example, it's not running on your on-premise application, right? On-premise servers. So in order to understand cloud, let's talk about what is the definition, or what you mean by cloud, right? So cloud computing is a type of internet-based computing, right? And what you get out of from that is it delivers different kind of services through internet. So in our previous cases or traditional environment, what you will have is You will have your own servers on your data centers or physical servers on your location, right? And you will have everything set up there. Now it has changed. Now it is more like you can get the different kind of services through internet itself. You don't need to set up your hardwares or data centers locally on your base location, right? So what cloud computing helps us is to deliver computing services, whether it can be servers or storage, databases, networking, right? Softwares, analytics, intelligence. It can be any kind of services, because currently in cloud, you can get any kind of services now. And these are all done through over in the internet, which is called cloud, and to offer faster innovation, flexibility of the resources, right? And economics of the economies of scale, right? Because you can scale this application. You don't have to pay all the time, pay as you go, right? That is one of the term you should know as part of cloud, right? So you typically pay only for the cloud services you use, and helping lower your operating costs, running your infrastructure more efficiently, and scale your business as need, right? And this is a definition as part of Microsoft, because what we are talking about is like in internet you have all these services available. And for example, you're going to procure a server from a cloud. You're going to use it, right? And you're going to pay only for the time which you are using it. If you're shutting down the server, you're not going to pay anything for that, right? And you have one server, and if you want to scale that server to 2 servers in cloud, it's easy. You can procure one more server, whereas in traditional your local setup, you need to buy one more hardware, and then you have to set it up, right? So those are the benefits of cloud. And the cloud computing represent the renting of resources from cloud providers, right? So what are the cloud providers? Like Microsoft Azure, AWS, like Amazon Web Services, Google Cloud, GCP, or IBM Cloud, or it can be DigitalOcean. And there are tons of cloud providers, and you're only paying for what we use, right? It's called pay as you go. So that's the term which you know about cloud. So you're going to use the cloud, and you're going to pay only for what you use. I hope that gives you some understanding or definition about cloud. Let me give you a scenario about cloud computing. So for example, there are different kind of developers, right? And you develop a web-based application which can be accessed through HTTP. Now what happens is some of the users access this web-based application through your web browser, right? So what happens is actually on the back end of this web-based application, there should be some servers, right, which will be running this. Maybe this web-based application is running on Apache Tomcat, or it can be web server, right? So all these servers are running on the back end, and you also may have some database to store some data, right? So all these things are running on the back end. Now a scenario happens like in the usage of this website has increased drastically, so that the load on these servers and database has become so high, so that you need to add additional servers, right? So in a normal traditional setup, you need to order physical servers, and you need to get those servers, you need to set up, you need to install everything, and you need to make that setup for easy accessing of this application from increased user count, right? Otherwise those users will get some performance issue. Whereas in the case of cloud, it's just some easy clicks, or you can set up all this configuration in your application itself, so that when the load goes high, it can easily replicate that your setup as a different set servers and databases, so that the load for your web-based application is distributed between multiple servers and multiple databases. So that's the benefit of cloud using when we use for scalability. So it's very easy to scale. Now let's talk about a little bit of different cloud service model which you should know. So I don't know, have you heard about infrastructure as service, which is called IaaS? Okay, so IaaS is infrastructure as service. This is one of the important cloud service model. So let's take an example, like you have Amazon Web Services. When you log in, you have different options to create virtual machines, right? You have cloud. You can create databases, you can create containers, right? So when we talk about infrastructure as service, what we do is, in the cloud providers, we create our own virtual machines or virtual servers, right? And using those virtual servers, we'll be installing something, or we'll be setting different kind of things using those servers. So that is called infrastructure as service. So we make use of cloud and we get some infrastructure like servers or databases, those kind of things, and we set up our application in cloud. So that is the basic definition of infrastructure as service. Whereas you also have something called platform as service. So in platform as service, you have infrastructure as service as a base. On top of it, you're going to get some platform. So when this is for some example I can tell is like Elastic Beanstalk, right? I think that's one of example. Other example like OpenShift. OpenShift is another example for platform as service, and other example like Heroku, right? So these are different kind of platforms which is given for developers for their use. So it's not an infrastructure we are procuring. It's a platform which is we can get it directly from cloud. So this platform as service gives the developers an environment for testing and deploying their application. Okay, so it's like a virtual environment, and that is the benefit of platform as service. So it's not like you have to get the infrastructure. So it's like it will give you the developers the complete freedom to test and deploy your applications. So it's more like a runtime environment for your running your applications. Okay, so that's a platform as service is different, and there is something third called software as service. So this is on top of platform as service. This is called putting a software, right? So we have infrastructure as service on the back, then we have platform, and top of it you can put a software. So here in this case, you can directly get a software itself from cloud. For example, Salesforce, right, where ServiceNow. So there are different kind of applications you can directly get from clouds, where you don't have to worry about your base infrastructure or platform. You're getting the software, you can just start using it. The backend, the cloud providers will take care. So using this software as service, you can directly give your software to end users, and it will help those users to start using, and you don't have to worry about anything about your backend infrastructure. So some other example for software as service are like GoToMeeting or some Slack. So those are some kind of application we can consider for software as service on top of like Salesforce or Google apps. So those are all software as service. So these are some basic information of cloud service model. So that's all I wanted to explain about introduction to cloud. So I think you got a clear understanding on what is cloud, what is the purpose of cloud, and what are the different service model, right? Now let's talk about Openstack. So what is Openstack, right? So you will be wondering what is Openstack. So Openstack is an open standard and a free platform for cloud computing. So Openstack is used to create a cloud computing environment. So mostly like we can create our private cloud using Openstack, and Openstack is also used by big giants like IBM or HP or Rackstack. So those people are using Openstack for different use cases. Okay, so in our case we'll make it much simpler. So Openstack as a definition, it's an open source component which help you to provide a set of software tools for building and managing cloud platform, but it can be public or private cloud, right? So using Openstack, this gives you a set of tools or software tools which you can use it for building and managing cloud computing. Okay, so if you want to set up your own cloud in a private cloud, you can use Openstack. You can get your infrastructure, you can set up Openstack, you can convert that into a private cloud, right? Well, same way in public cloud as well, you can use Openstack. So we will talk about what are the different models of Openstack. So I just want to give you a brief introduction in this section, then we will talk more about that. Okay, so as I mentioned, OpenStack is deployed as infrastructure as service, where virtual servers, other type of resources is available for user, where components like networking or storage, hardware processing, etc. and all these are controlled through data center provision through APIs and common authentication mechanism. Okay, so once you install OpenStack, your base hardware, it will be converted like infrastructure as service. On top of that, what you can do is you can create your virtual machines, or you can create your network. You can create different kind of hardwares. You can create containers. So all these options you will have it in OpenStack, and all these things you can easily do as well through APIs and some common authentication mechanism in OpenStack. Okay, now let's give you a brief history on OpenStack. So OpenStack began as a joint venture or joint project of NASA and Rackspace. Rackspace is one of top company on cloud. Okay, and in 2020 it was it's a joint project, but later what happened is they handed over this project into a foundation or a community called OpenStack Foundation, and this foundation have all these big giants like IBM, HP, Rackspace. So a lot of companies are there as part of this OpenStack community, and Red Hat is one of a big contributor in it, and they all contribute to this open source project, and that's why it's widely used by a lot of companies, and it's an open source, so you can use it, you can modify it, you can do anything you want with this open source code as well. So that is the benefit, or why OpenStack is used now by a lot of company, and creating their hybrid cloud environment or private cloud environment. So all those things they are using OpenStack. Now let's talk about a little bit about the OpenStack deployment models. So basically there are different kind of categories or deployment models we can talk about. So first one is OpenStack on-premise. So what does this means? Like, as per the name itself, you can set up your OpenStack on-premise. So for example, you can buy some physical servers, right, with huge memory, huge CPUs, storage. Then you can set up OpenStack on top of it. So that looks like more of a private cloud, right? Then on top of it, you can do whatever you want as part of your private cloud setup. So this is the vast and highly used setup for OpenStack. So let's talk about the second one, which is called OpenStack hosted cloud. Okay, here the scenario is like you have different cloud vendors, like whether AWS or Azure, IBM, GCP. You can request the cloud provider itself to give you an OpenStack environment. So that means this setup is hosted in cloud, whether it can be public cloud, or it can be using a specific standard VPC or standardized network, and specific for your organization itself in the OpenStack environment. So that we can call it as a private cloud, hosted cloud as well. But it's not an on-premise, it's more of from the vendor cloud service provider. You are going to get that. Okay, and the third one is like OpenStack appliances. So there are also appliances like hardware appliances where you can run OpenStack directly. So that is what it meant by OpenStack appliances. And there is one thing called OpenStack as a service. So as this name, like software as service, this means like you are going to get only OpenStack as a service. The backend, the cloud providers will run whatever they want, but for you will get a link or something which you can log in, and you can make use of OpenStack all features. But the backend, how it works, you don't have to worry, because only thing you have to worry, they are giving it as a service, and you start using it, all the rest they will take care. Now let's move on to the OpenStack architecture. Don't get too much worried about seeing this, because you may see, oh, this is too much complicated, there are so much of components in OpenStack. Yeah, there are a lot of components, there are a lot of things which you need to know, but we will simplify this and then we'll come back again to this page, so you will see, okay, it's not that much difficult as you think. This looks like too much complicated, but it's not that much. So in order to simplify that architecture, I want to discuss about a few components. So let's start with Horizon. The Horizon is the dashboard or user interface for OpenStack. We will talk a little bit more detail about this topic in the later section. But I just want to give you the names of these components which we just saw in the previous presentation, which you would have felt like, oh, so much of component, so much of line going from here and there. So the next component is called, or service is called Nova. Nova is the compute service for OpenStack. Okay, and there is another component called Swift, which is the object store for OpenStack, and there is another one called Cinder, which is the block storage. So now we see like a Horizon, which is the user interface or dashboard. Nova is the compute service, Swift is the object storage, and Cinder is the block storage, right? And there is something called Neutron, which is the networking service. Okay, and you also have something called Heat, which is the orchestration part, and you also have Glance, which is the imaging services for OpenStack. There are more which we will see, okay, but I just want to focus on these few important components. There is something called Ceilometer, which is the telemetry, or the one which uses to get the full details, or get the usage details, how to bill it. Those things are done using Ceilometer. And there is also something called Keystone, which is completely managing the identity management, which gives the authentication for all these services. So without Keystone, you cannot have running any of this, because all these things which need to do any action, it has to be authenticated using Keystone. Okay, so let's talk a little bit more about each component. So in order to talk about Horizon, so the Horizon is the canonical implementation of OpenStack dashboard. So that means it is the front end or the dashboard for OpenStack, which provides you the web-based user interface, right, for users or OpenStack services. So if you get the web page, so to log in, that is the page for Horizon, and inside the Horizon you will see all other services, right, which you can make use of it inside the, like cloud. You go to the web login, you create VMs, you delete, you make networks, right? So all those things are done on the web interface, right? You can also do through APIs and command line, but we are talking more about the Horizon dashboard now. Now let's talk about Nova, or compute engine. So Nova is the OpenStack project that provide you a way of provisioning compute instances, right? So what do you mean by compute instances? Like creating virtual machines, creating bare metal servers, right? And it has a very limited support for system containers, but mainly we are focusing on virtual machines and servers, right? So Nova runs as a set of daemons on top of existing Linux servers to provide that service. So as I mentioned, once you log into the OpenStack environment, you have options to create Nova or compute services. Once you create, you will get VMs or servers, right? So that is the compute engine part of which is the Nova service. Now let's move on to Swift, or object store. So Swift is the highly available and distributed, eventually consistent object or blob store, right? So organization use Swift to store a lot of data efficiently, safely, and cheaply. So if you don't know about object store and block store, I would request you to have a look on that, so you can find the difference between what is object store and what is block store, right? So block store is more like a old method, right? So Cinder is the OpenStack block storage service for providing volumes to Nova virtual machines, or for bare metal hosts or containers, more etc., right? So block store is more like your data is stored as part of blocks. It does not have any meta information, whereas Swift you have meta information, and the data will be called based on the meta details, right? So that is the difference, but I would say like you can read through that. This topic is completely different out of this, so I'm not going to talk much about what is different between object store and block storage. Now let's talk about Neutron. So Neutron is the OpenStack project to provide the network connectivity as a service, right? So between the interface devices managed by other OpenStack services, like for example, you have Nova Compute Engine, you are creating different virtual machines, right? So all this networking has to be done, and that will be done using Neutron, right? So it's implemented, it implements the OpenStack network APIs. So you can have network APIs as part of Neutron, and you will be able to use that for different purposes as well, right? Now moving on to heat. Heat is the orchestration component. So heat is a service to orchestrate composite cloud application using a declarative template, right, through OpenStack REST API. So this heat template describes the infrastructure of cloud application in text file, which can be readable, writable by humans, and can be managed by version control tools, right? So orchestration means, like, you have YAML files, or you have templates where you'll be defining some components, and once you run it, it will deploy that, right? And we're in our case, the heat templates. So in order to deploy something on your OpenStack, you can use heat templates as a readable, writable format, or in a text file, and then it can be stored in your some version control tool like Git or Subversion, and you can manage it. Now let's moving on to Glance. So Glance is the image service which provide users can upload or discover data assets that meant to be used in other services, right? So this currently includes images and metadata information, and Glance images include discovering, registering, retrieving virtual machine images. Glance has REST API that allow you to query via image meta as well as retrieval of actual image. So Glance, you will have image services. So using that, you will be able to include different kind of images. You can set some meta information. You can use that to retrieve, and you can build some VMs on that using those images. So for example, if you have a Ubuntu application, if you want to set up a Ubuntu server, you should have Ubuntu images in Glance, right? So that is how Glance works. So that is all you need to about Glance. And you also have something called Celometer. So Celometer, as I mentioned, it offers a single point of contact for many billing system, facilitating each counters they require to build custom billing around every feature or current components of OpenStack, right? So the Celometer is mainly focused on the billing to understand the usage of your OpenStack component, and then it will be used to build your OpenStack usage, right? So once you create a private cloud using OpenStack and you are giving to users, you need to have some method to identify the usage and do the billing for customers, right? So that's the Celometer benefit. And you also have something called Keystone. This is very important because Keystone is the OpenStack service that provide API client authentication or service discovery or multi-tenant authorization using OpenStack identity management, right? So any components, whether it's Horizon, like you want to log into a dashboard, you need some authentication that is done through Keystone. Whether Nova, you want to deploy, create some virtual machine, you need some authentication that this user can do it. So the same way, like any component, this Keystone is very important because your whole authentications is or your identity is managed using Keystone. Now what we discussed is only very few components. So there are a lot more components in OpenStack services. You can see Nova we discussed as a compute service. There are something called Zune, which is called container service. There are hardware lifecycle like Ironic, Cyborg, and there are Swift and Cinder we already discussed. There is also something called Manila, which is the shared file system. You have networking, you have Neutron we already discussed. There is something called load balancer service like Octavia, DNS service like Designate, Keystone we already discussed about identity. There is also something called placement, Glance we discussed, Barbican, which is a key management. In the case of orchestration, Heat we already discussed. There is something called Senlin, which is a clustering service. There is a workflow service called Mistral. So there are a lot more. Okay, I don't want to read through all these things. What I would suggest is, like, you look to the video description. I'm linking all these things there, and also I'll be linking my GitHub link where you'll be able to see all the details about the commands, all the reference links over there. Okay, so just like look into the video description to get all the details. You can also see, like, in the front end, you have also something called Skyline, which is the next generation dashboard, which is a tech preview, right? So a lot of things which you can refer it here. Now if I go back to the previous screen where we discussed about or shown these OpenStack components, right? So now you can see you have users, right? And they are going to connect to Horizon, which we said, which is the OpenStack dashboard, right? And we have Heat here, right, which is the orchestration, right? We have the bare metal service over here. and you have keystone, right, which is the authentication for all. We have ceilometer here, which is used for telemetry, right. You also have Nova here, which is going to create your virtual machines. We have something called Trove, right, which is the OpenStack database service. You have Swift here, which is your object storage, right. You also have block storage, which is your Cinder. You have Glance, which is your imaging service, right. So you have image service, Glance. We have Neutron, which is your networking service, and you have something called Sara, which is OpenStack data processing, right. So now this will be much easier for you, right. You may have thought first cases like it's too complicated, so much of components going line here and there. But now I think you should have understood what is horizon, what is heat, what is keystone, ceilometer, Swift, right, Nova or Cinder or Glance, all these things, Neutron. So I think you should be able to understand all these things now. So this is another landscape for OpenStack. So if you see, this is the same thing which we discussed in the web page. So all the components, right. So the front end we have horizon and the EC2 API, right, and you have other workload, provisioning, application, orchestration. These are the compute services. These are the storage services. This is the networking part. This is the hardware. This is the keystone and the shared services, right. And we have other tools like ceilometer, watcher, and all those things. We have client tool like OpenStack client, SDKs. So this is a simple other OpenStack landscape. So I will link this page as well, where you'll be able to get the complete details about the the components which we discussed. Okay, so that's all about OpenStack components, and now we can get into the actual installation part. So now we are going to see how we can install OpenStack. Okay, so as part of the installation, what we are going to do is we are going to do a installation using for our development environment. Okay, so we are going to use something called packstack. So that is something which once you run it, it will install all these components by itself. So we are not going to use any standard one by one separate installation, which you may do. You can do it for your production separate environments, but what we are going to do is we are going to create a packstack, which is more of a development environment to learn about OpenStack. Okay, you can use that if you have a good highly efficient resources like huge memory, huge CPUs, huge storage. You can use that as well there if you don't want to have a separate installation. But in our case, we are going to use a virtual machine. We are going to set up a Oracle virtual machine, which may be around 5 to 6 GB of RAM and good storage and a few CPUs. And on top of that, we are going to install OpenStack using packstack, and we will be able to make use of that as an OpenStack development environment. Okay, so let's get started without any further ado on that. So let me open my instance from Oracle Cloud, not Oracle Cloud, Oracle Virtual Machine. So you see I'm inside my virtual host, so which is a CentOS machine, and we are going to set up our OpenStack on this machine. Okay, so I will run a lot of commands to install OpenStack. Don't worry, I will give my GitHub link into the video description, so you can get all these commands into the from that GitHub link, so you can just copy and paste it. Okay, so first thing what we are going to do is we are going to temporarily disable the SC Linux, so we are going to run that command. So these are some prerequisites which we are doing. Okay, so that it's not a, as I mentioned, this is not a production setup, so you may not be doing the same stuff when you're doing in the production setup. Okay, so because sometimes we are going to disable firewall here, which we should not do it in your case of your production setup, right? So disabling firewall may not be a right option for you. So as I mentioned, what we are going to do is we are going to disable the firewall D. So I'm just running this command, so it has removed the symlink, so that when your system reboot, it does not have the firewall D, right? And I'm going to stop the firewall D as well. So I'm going to use stop. Okay, so that part is done. So our service for a firewall is also stopped. Now what we need to do is I also need to make some changes on the networking side. So let me do that. So I'm going to disable the network manager itself. So as I mentioned, in your production setup, what you will have to do is you have to configure your networks, you have to configure your firewall ports and everything, so that you don't have to disable it. Okay. But this is, as I mentioned, it's a packstack installation where we are going to use like a development environment. So this one you can just follow this step straightforward and you can start learning OpenStack. Okay. Now let me stop this network manager as well. So we are done with our pre-request. Okay, so our pre-request steps are done. Now what I want to do is I also want to remove some of any EPL releases. So if you had some other repositories are installed, I don't want to make a lot of conflicts in the installation part. So I want to remove anything based on that. So let me remove that. And I also want to see whether any OpenStack packstack installation was there. So because any residual content of previous components which will cause a lot of issues, so I want to clean those things before we do our installation. Okay, so I'm going to I have tried running the remove OpenStack packstack, so there is nothing. So I have done that now, and I also want to clean things. Okay, so I'm going to run yum clean all, so that it can clean all those things. Okay, so we are done from that part. So our system is ready, clean, and now we can install our OpenStack. So in order to install OpenStack, you should know like which version of OpenStack, right? So what I will do is I will search in the CentOS release, like what all things are available to install, because you need to know which repository is available, right? So which version of OpenStack is available in the CentOS release. So I will just search it. Okay, so let's wait for this to be completed, then we will see, because there are different versions of OpenStack. So we will see what we get in the output. Okay, now if you see the search is completed, and what we can see is like we have Queens, Rocky, Stein, and Train, right? There are other versions of OpenStack as well, like Yoga. So if you don't have those in the repos, you cannot use that. Okay, so you need to check which OpenStack release is available, and based on that you can install it. Okay, so let me clear out this screen. So what we are going to do is we are going to install stain.norc, right? So we had that in the repo, right? So we are going to use yum install -y for all this installation, because it does not ask for me yes or no, and we are going to give the name. Okay, the release CentOS release OpenStack, and the name stain.norc, right? So let me run that so that it can start installation. So you can see it has started the installation, and it has completed that as well. Now what we need to do is we need to do a yum update. So I'm going to use yum update -y so that it can update all the repos and the components. This may take some time, because depending upon your the file it has to download, it will take time for this whole process. Okay, so you can see it has around 203 right components, and it's running those things. So I will pause the screen so that it can do the whole installation, and once the installation is completed, we will check. There are a few more steps we need to do, so we will talk about that as well. And meanwhile, if anyone is thinking about what is the system settings, or like what is the CPUs or memory I use for this Oracle virtual machine, you can set up a virtual machine which is about 6 GB. So if it's less than 5 GB, I think it will not work, because your OpenStack is a heavy software, and you need good memory and CPUs for creating your components, right? Because you need to distribute these components for compute and other things. So you set up a Oracle virtual machine which is more than 6 GB of RAM, and you can have 3 to 4 CPUs, vCPUs. Okay, so you can put that, and you can put a hard drive space of around 30-40 GB. That less than that is also fine, but you can put a little bit more, and then you can create a virtual machine, and then you can do this installation. So I will pause the screen so that let this installation complete, and we will come back after that. So the installation or the update is still going on. So as I mentioned, this will take a few minutes, then based on that it will complete the installation. So you can see the update is completed, so it has taken around 10 to 15 minutes for me. So in your case it may be less than that or more than that, depending upon your network speed and also how much of file it has to update. Now let me clear on the screen, and we are going to install the OpenStack packstack, right? So yum install -y OpenStack packstack. Okay, so we are running that. So you can see this will also take some time because it has to download a lot of packages, right? You can see 137. So it will download, it will install, right, and clean up. So all these activities it has to do. So once the packstack is installed, we will come back again to do our next step. Okay. This was much quicker than yum update. It has taken only just a few minutes. So let me clear out the screen. Now we can start the packstack. So for that we'll use packstack -- all in one. Okay, because as I mentioned, we are not going to create separate services. So this will start all the services for whether it's Nova or Neutron, or all these services will be started by the single command. So let me run that. Okay, so you can see packstack installation. Now you can see it is setting up something, right, cleaning up, discovering protocol versions, setting up SSH keys, preparing the servers. So let's wait for all this to be set up. You can see the process is keep going on, right? And you can see it has created SSH key for Nova, host key, right? It has set up Neutron. It has done the Horizon, right? Swift, it has done the ceilometer. So all these things you can see it's still doing a few more things, so we have to wait. I'm not sure if you have noticed, like it has also we have discussed about all these components, like you can see like Keystone, Glance, Cintor, right? All these Nova, whatever we discussed, all these components are here now, right? So all these are started as part of this single command. Now we are still in the process, it's not completed the whole process, so we'll wait. Now you can see the installation is completed successfully, so you can scroll up and you should be able to see all these. And you can see also it has mentioned like a root keystone RC admin has been created on OpenStack, the client host. And in order to access the dashboard, you need to use this link, which would be the IP address of our machine, and we need to log in. So if you copy that link, like your IP address and dashboard, you should get a screen where it will ask you to log in with your username and password. So the username should be admin, and you should get the password for this account. In order to get the password, you need to use the file which it has mentioned. It has stored the content for your account, right? So let's clear out the screen, and if I check this current location, you can see the file called keystone rc admin, right? So if I cat this file, you should be able to get the password, right? So the username is admin and the password is this one. So you can just copy this content and you can paste that into your login page. Okay, and you can click on sign in. So that should be your username and password to log in. So you need to go to the place where your keystone rc admin file is there, and you can read the content. So you should get the password, default password for your login for OpenStack. Okay, so I've just entered your username and admin, and I'm just clicked on sign in. So I'm waiting for the login page. Now as you can see, we are logged into the OpenStack page, and you can see the list summary, right, where you can see the compute instances, the vCPU, right, the RAM, and the volumes, the network, the usage summary, the instance. When we create the instance, you can see that, and you can also see like the options called instance, images, key pairs, right, server groups, volumes, network, object store, the admin page, the identity. So all these services which we talk, right, we spoke about compute service, Nova. We are currently inside the Horizon, right? We logged in into the Horizon, which is the dashboard, and you also have like identity or keystones. So all these things are available now inside this, and you can set up your infrastructure, you can configure your network, all these things inside your OpenStack. So this is what the basic information I wanted to show you, like how to set up OpenStack. To understand more about each components, we will have separate video on that, but I hope you are able to create your OpenStack first instance using packstack, and you are able to start using it. So as I mentioned before as well, all these commands which I have used to install the OpenStack, I will put it into my GitHub link, and I will link that into the video descriptions, so you can just copy and paste those commands in the setup. Okay, and we also explained about each component, so you can if you have not seen the whole video, I would request you to watch the whole video to get the complete information on what is OpenStack, and what are the different components, what is the architecture, and how to install it, all those details. So that is all for this tutorial. I'm sure it's an informative tutorial and useful and exciting tutorial for you. But before I get close this video, I would request you, like, if you're new to my channel, or if you're not subscribed to my channel, I would request you to click on the subscribe button. Also like my videos, share, give your feedback in the comment section, and thank you for watching.